All right, so it took me a little while to figure out what this problem was even really asking. And I figured out that the main issue with this is that normally when we do dihybrid crosses, especially with double heterozygous crosses, when we do them in AP Bio, normally what we do is we actually go through and we do two alleles or two traits, two genes that are in no way linked together. So I think the one that we mostly did together was flower color and pea color. So pea color never affected flower color never affected pea color, so you didn't have a whole lot of the genotype issues that you have on the bottom here. Once I figured out that that's kind of what the problem with this one was, I needed to get an idea of what each of these actually looked like, what the phenotypes were, because I wasn't initially familiar with what these color typings actually were. So I decided to go ahead and pull up some of them for you. So you've got your normal boas, your anery colored boas, your albino boas, and your snow colored boas. So that's kind of where I got started with this. So then when you go through, we're going to actually use this as we go along for that. So your normal boas are going to be controlled mostly by the, that worked well. Your normal coloration is going to be controlled predominantly by this A allele. So this is going to be giving you your normal coloring. And then on top of that, so for those two, you have the dominant, which is normal. And then you have the recessive, which is albino. So that's going to be that A trait. Your Y trait is going to be this second kind of grayscale coloring. So the grayscale coloring is actually going to cover up entirely the A allele. So the Y allele is more dominant. So whatever the Y allele says really goes. So here you have the dominant Y allele essentially being nothing. So it's just turned off. And then your recessive here is going to be, you can consider it turned on. There's an R in that word, turned on. So whenever you have this, your normal is going to have some variation of dominance. See if it will actually let me write next to these. Nope. Okay, so your normal is going to have some sort of dominant structure. So it could be AA, it could be A lowercase a, so heterozygous. But the important thing is that it's going to have at least one dominant Y. And it has to have at least one dominant Y because otherwise it would be turned off and it would be that anery grayscale. So here we could have dominance, we can have a recessive there, and then you can also have that switched up. So you could have your dominant A's with a heterozygous for the anery, and you could have heterozygous there with a dominant for the anery. The only way that you're going to get that anery color is if you have a normal A, so anery, is going to be that quote-unquote normal color pattern, but with a turned on anery chain. So essentially when we go back up here and we look at it, it's just the normal coloration turned grayscale. Don't need that. So then when we come down to the albino, it is the albino here, so it's going to be recessive for A, and we want the anery, the grayscale chain turned off. So we need recessives here, and then we need the grayscale turned all the way on or turned partially on. And then the only way to get the snow, so we can just see that that's the normal and the albino, and then we need the snow is essentially the albino but also grayscale. So the only way that we're going to get that is to be totally recessive. So when we look up here, the snow is essentially this anery grayscale, or is essentially the albino with the grayscale. So there are a bunch of unnecessarily complicated names for this. So you have your normal genotype, which we decided has to be dominant, 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 dominant. And then it's going to go into all sorts of different other kind of groupings of this. So that's not at all what I wanted. Sorry, this is kind of hard to see. So these are all your phenotypes up here. So these are the general phenotype descriptors. And then down here, these are going to be our genotype breakdowns. So we can see that we only have one of those, so that's where we get our just one normal. I did these a little bit different on the worksheet I pulled up, so let me take a look at the picture as we go along. Okay, so then we've got the heterozygous anery is the next one. Well, we know that there has to be, that heterozygous anery has to be referring to this Y, this turned on and off grayscale being heterozygous, but it still needs to be, I'm pulling it up in my head, but it still needs to be that normal color. So here it's referring to it being heterozygous for the anery coloration. And then we've got just our regular anery, which we know has to be recessive. So it has to be dominant, dominant, lowercase, lowercase. So essentially all that it's done for these top three is the top three are all the possibilities for a homozygous dominant A allele. So that's how they're kind of sorting them, is by their homozygous dominant, or their A kind of dominance there. And then it's moving on to the Y. So heterozygous for albino. So now we're moving into the kind of next stage down. So now we're talking about the A allele again. So heterozygous albino. We know since albino is not talking about the grayscale, it has to be heterozygous there. And then it's going to be dominant for that grayscale there. Next up, wish my phone would stop turning off. Next up, we have our double heterozygous. which was an easy one for me to figure out because it's literally just hetero, both of them being heterozygous. That's kind of where I started in looking for them. So after we've got that, we've got an anery heterozygous snow. Wow, that's not what I wanted at all. Okay. So because it's anery heterozygous snow. So here, because it's anery, would you stop that? We know it has to be homozygous recessive for the grayscale. Good glory. Sorry, it keeps jumping all over the place. So here it's still going to be, really? Now we're not going to draw? Okay. So it's still going to be heterozygous for that snow color or heterozygous for the albino color, but it's also going to be anery colored. So these are all possibilities. For heterozygous A allele. And so finally, we're going to get into the homozygous recessives for the A. So those are going to be your plain albino, which is going to be little a, and then we're just going to leave the anery trait out entirely. And then we've got albino hetero snow. So we're getting closer to the snow coloration. So that's going to be albino still. And then we're going to make it heterozygous for the snow. And then your snow coloring is going to be completely homozygous recessive. So these are all possibilities for homozygous A allele. So that's how they have them kind of ordered out, is it's organizing it by the A allele. So you've got homozygous dominant A, heterozygous A, homozygous recessive A, and then it's taking into account homozygous dominant, heterozygous, homozygous recessive for that grayscale or that anery. And then that's kind of where the names come from as well. I hope that helps. If it doesn't, let me know. Yeah.